Hello everyone, in this video we will be looking at some worked examples of successive differentiation. At first let's have a look at the steps. In step number 1 we will determine y1, y2, y3 and y4. Now what is this y1, y2 or y3? Basically if you differentiate a function once you get y1. If you differentiate a given function twice you get y2. Similarly if you differentiate a function thrice you get y3. Now in step 2 we have to look at y1, y2 and y3 and determine if there is any pattern. Lastly, in step number 3, based on the pattern we got in step number 2, we will predict yn. Now all these things may seem a bit confusing, but when we will look at the examples it will be easy. So let's have a look at our first example where the function is e to the power ax. So according to our step 1 we have to find y1, y2 and y3. Now, if we differentiate the given function e to the power ax, according to the formula ddx of e to the power ax equal to a e to the power ax, we get y1 as a e to the power ax. Similarly, if we differentiate this function again, we get y2. So, if we differentiate a e to the power ax, we get a square e to the power ax. As there was already one a and we differentiate this part again and we got a e to the power ax. So, a into a equal to a square. Using the same formula, you get y3 as a cube e to the power ax. Now in step number 2, we determine the pattern. We can see that there is a pattern. In case of y1, it is a, in case of y2, it is a square, and in case of y3, it is a cube. And in every of the functions, there is an a to the power ax. And in our last step, we have to predict yn based on the pattern we got in step 2. So, yn equal to will be a to the power n into the part which was with all the y's, which is e to the power ax. Now, your task is to do question number 2 and let me know in the comment section below the answer. Now, let's have a look at problem number 3 where the function is 1 by x plus a. At first, we can write this function as x plus a to the power minus 1. You all know that, right? Now, to find y1, y2 and y3, we have to differentiate this function. And according to the formula ddx of x to the power n equal to nx to the power n minus 1, we get y1 as minus 1 x plus a to the power minus 2. Similarly, we have to find y2 by differentiating y1. And if we differentiate y1, we get minus 1 into minus 2 into x plus a to the power minus 3. Why? Because this minus 1 is this minus 1 and this we differentiated this part and we get minus 2 in the front and x to the power a minus 2 minus 1 which will be minus 3. Now let us break it down a bit. We can write minus 2 as minus 1 into 1 into 2. We basically did this to see the pattern. We will see it after a while. And we can write x plus a to the power minus 3 as minus of 2 plus 1. Why did we write it this way? Because there is y2. To match the pattern, we wrote 3 as 2 plus 1. Now, in the similar way, let us find y3. And if we do the same things like y2, we will find minus 1 to the power cube into 1 into 2 into 3 into x plus a to the power minus of 3 plus 1. Now we can see there is a pattern in y1, y2 and y3. And in the last step we have to determine y1. So what will be y1? y1 will be minus 1 of 2 to the power n. Why? Because in case of y1 the power of minus 1 is 1, in case of y2 the power of minus 1 is 2, and in case of y3 the power of minus 1 is 3. So in case of yn the power of minus 1 will be n, and we can see that in case of y1 it is here is 1 which we didn't write here. In case of y2 it is 1 into 2, and in case of y3 it is 1 into 2 into 3. So in case of yn obviously it will be 1 into 2 into 3 into dot 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 to n. And lastly, about this part x plus a to the power minus 3 plus 1, in case of yn it will be minus of n plus 1, because for y3 here we had 3, for y2 here we had 2. So basically that's our answer. Let us break it down a bit. We can write 1 into 2 into 3 dot 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 n as n factorial, and since this part's power is negative, so we can write it as denominator. So our final answer is this one. Now your job will be to solve problem number 4 and let me know the answer. Now let's have a look at problem number 5. Here the function is y equal to sine of ax plus b. So at first we have to differentiate this function sine of ax plus b and find y1. And we know ddx of sine x equal to cos x. So if we differentiate this part, we will get cos of x plus b. And according to chain rule, we have to differentiate the inside part as well. And if we differentiate x plus b, we get a into 1 plus 0. So a into 1 comes forward. Here is this a. Now let us convert this cos to sine, because we will need it for determination of pattern in step 2, and we know cos theta equal to sine pi by 2 plus theta. So we wrote an extra pi by 2 here and changed it from cos to sine. Now let us find y2. Similarly, we have to differentiate this y1, and we will get this part. So, ddx of sine x equal to cos x. That's what exactly written here, and we have to differentiate the inside part according to chain rule. And if we differentiate the inside part, pi by 2 plus ax plus b, we find 0 plus a into 1 plus 0. So the a comes forward, and with the previous a it becomes a square. Now let us again change this cos to sine, and as we know cos theta equal to sine pi by 2 plus theta, so we changed it from cos to sine and added an extra pi by 2 here. So we can write this pi by 2 plus pi by 2 as 2 pi by 2. So that's our y2. Let's not cut this 2, as this will help us to determine the pattern, because there is 2 here. Now let's differentiate this part again and find y3. If we differentiate this part, we will get a cube cos of 2 pi by 2 plus ax plus b using the same formula. And let us again change this cos to sine using the formula cos theta equal to sine of pi by 2 plus theta. So we added an extra pi by 2 here and changed from cos to sine, and after simplification we get it as 3 pi by 2 plus ax plus b. Now looking at y1, y2 and y3, we can see there is a pattern. In case of y1, the power of a is 1, in case of y2 it is 2, and in case of y3 it is 3. So in case of yn, obviously it will be n, and since in all the functions of y there is sine, so we wrote a sine. And in case of y3 it is 3 pi by 2, in case of y2 it is 2 pi by 2, in case of y1 it is 1 pi by 2. So obviously in case of yn it will be n pi by 2. The rest of the part is same, ax plus b, x plus b, x plus b. So the last part will be ax plus b. So that's our answer. Let's have a look at problem number 6. Basically 6 is same as problem number 5. You can just try it yourself and match with me. So let's have a look. Here the function is cos of ax plus b. First we have to find y1, and we know if we differentiate cos x, we get minus sin x. So differentiating cos ax plus b, we get minus of sin ax plus b. And according to chain rule, we have to differentiate the inside part as well. And differentiating this inside part, we get a into 1 plus 0, which is basically a. So the a comes forward. And let us change it from sin to cos, so that we can bring pi by 2, and like the previous math, we can determine a pattern from pi by 2. And we know sin theta equal minus of cos pi by 2 plus theta. So we changed from sin to cos, and there was another extra minus. Minus got cut off, and we wrote pi by 2 extra here. Now we have to differentiate this function to get y2. If we differentiate this function, we get minus of a square sine pi by 2 plus ax plus b. Why? Because according to the formula, ddx of cos theta equal minus sine theta. Again we have to change it from sine to cos, so that we can bring an extra pi by 2 here. And according to the same formula, sine theta equal minus of cos pi by 2 plus theta, we can write it as a square cos pi by 2 plus pi by 2 plus x plus b. Basically this part is the same. We just wrote an extra pi by 2 here and changed from sine to cos. And here in this part it is just simplified. Pi by 2 plus pi by 2 equal 2 pi by 2. Similarly, in the same way, we have to find y3 by differentiating y2, this part. If we differentiate this part, we will get minus of a cube sine theta. And since we have to change it again from sine theta to cos theta, there will be an extra minus here. According to the formula, sine theta equal minus of cos pi by 2 plus theta. And this whole part is the theta, and there is an extra pi by 2 as we changed it from sine to cos. If we simplify it, we will get a cube cos 3 pi by 2 plus ax plus b. Now looking at y1, y2 and y3, we can determine the value of yn. Why? Because in case of y2, the power of a is 2, in case of y3, the power of a is 3. So in case of y1, obviously the power of a will be n, and in every cases there is cos. So there will be cos. And in case of y1, it is 1 pi by 2, in case of y2 it is 2 pi by 2, and in case of y3 it is 3 pi by 2. So obviously in case of y1, yn, it will be n pi by 2. The rest of the part will be same, x plus b, x plus b, x plus b, x plus b. So that's our final answer. Now let's have a look at our last example. Here I will go a bit in short, not explain each and every line since I have done it in the previous maths. Here our function is y equal to sine 3x into cos 2x. At first, let us take an extra 2 to match with the formula 2 sine a cos b. That's why we wrote 1 by 2 into 2, which is basically 1. So we brought an extra 2 here, and according to this formula 2 sine a cos b equals sine a plus b plus sine a minus b. We can write from this line into this line. This half 1 by 2 is written as it is, then 2 sine a cos b. So sine a 3x plus 2x plus sine 3x minus 2x. Here the bracket is given a bit wrong, bracket will be here. So if we simplify this, we will get half into sine 5x plus sine x. Basically we added this part and we subtracted this part and wrote here. Using this formula we got this part. Now you have to find the differentiation of sine 5x plus sine x. You will get this part for sine 5x. If you differentiate this part sine x, you will get this part, and then add this part, and then if you find y1, y2 and y3 and lastly yn, you will get half into 5 to the power n into sine n pi by 2 plus 5x plus sine of n pi by 2 plus x. Basically there will be the steps in this part. I did not do this part. Please practice this math and do this part and match with this answer. So that's the end of our today's video. Stay safe and spread positivity. Thank you.